Hello everyone, welcome to the next module on basic electrical engineering. It is about DC circuits. So this will be the outline for this DC circuit module. At the end of this session, learners are able to classify different types of electrical networks, reduce the electrical network using series and parallel star delta conversion, apply KCL, KVL, superposition and Thevenin's theorem. So let's introduce about the electrical circuit first. Electrical circuit is a conducting closed path provided for the flow of current. Electrical circuit is only what? Closed path provided flow of the current. In terms of circuits and networks are circuits and networks are used synonymously in electrical engineering. Circuits and network both are the similar word. The electrical circuit which is supplied by the direct current is called DC circuit. Okay, the electrical circuit which is supplied by the DC current, it is known as the DC circuit. Is consist active and passive element. Active elements are the sources of energy, whereas the passive elements are the resistance, inductance and capacitance. So active elements always have a sources and passive elements are what? Resistance, inductance and capacitance. Analysis of electrical circuit means find out the current flowing through and voltage difference across the circuit. Okay, it is what? Find the current flowing through on voltage across the circuit. In general, there are two methods of analysis of circuit. One is the direct method. In this method is restricted fairly for simple circuit. This is applicable only for simple circuit. In this method, circuit is kept in original form while analyzing. There is no reduction. What? Circuit is kept in original form. This uses the Kirchhoff's law, superposition theorem, Thevenin's theorem. Next one is the what? Network reduction techniques. This method is used for simple as well as complicated network. Here original circuit is converted into the simple equivalent circuit by the various methods such as series parallel simplification, star delta, delta star conversion, Thevenin's circuit or Norton's theorem. So there are two techniques. One is the direct method and second one is the network reduction technique. So let us understand some circuit terminology. So what do you mean a principal node? A node where three or more than three branches are meeting, it is called as principal node or junction. Okay, a point where three or more than three branches are meeting. Okay, so see here in this figure the point B and point E. At this point B and E there are three branches are meeting. At point E there are three branches are meeting. So we can consider that point B and E are the principal nodes. Subnodes, a point where two branches are meeting are known as subnode. Here point A, point C, point D and point F. Here there are what? Two branches are meeting, hence it is called as a subnode. Branches, it is the portion of circuit which connects the two nodes. Branches means what? It is the portion which connects the two nodes. Okay, two nodes or junction by the element. So here A, B, B, C, C, D, D, E, E, F or E, F and A, F. These are all what we can say. It is called as the branches in the circuit. Next we'll see what is a loop. It is the path which originate at the particular node and terminate on the same node. It is the path which starts at a particular node and which terminate at end node, traveling through the circuit. So here we can observe in this figure there are three loops. Here if we start from the point A, again from point A, B, E, F, A, this is one loop. Another loop is B, C, D, E, B. B, C, D, E, B is one of the loop, and another loop is A, B, C, D, E, F and A. This will form a third loop. So we can say that we are starting from the one node and again we are reaching at that node. Mesh is also closeless course path similar to the loop but does not contain other loop. So difference between loop and mesh is what? It does not contain any other loop. There are three independent. So here you can observe this outer loop consists two inner loops. So this is considered as a loop. It is not a mesh. But if we only take these two, then these two are mesh, which is not consisting any another loop. So it is called as the mesh. Okay, here we can see A, B, D, A is one loop. Okay, or you can say A, B, E F A is one loop, B C D E B is also one loop, which is a mesh. In figure B also, A B D A, B C D B. Okay, all mesh in this case all meshes are the loops, but it is not meshes. It is loops, but it is not meshes. In figure B, A B D A, B C D B, and A D C E F A, these are what you can say, these are the three independent loop which does not consist any loop, so it is called as a meshes. So this is also called as meshes. Circuit elements, any individual circuit component is known as the circuit element. Any individual circuit component is known as circuit element. That is R, L, C, R, that is inductance, resistance, inductance, capacitance are the circuit elements. Okay, so let's see the classification of the electrical network. The electrical networks are classified. First, it is classified as active network and passive network. Active network are those network which contains at least one or more energy sources such as voltage or current source along with the other elements. So in active source, at least there is a presence of any source, which may be voltage source, current source. Okay, so there any source will be present there, so we can say that it is active source. The passive source is only element, is circuit is only element without any energy source. Resistance, inductance and capacitance are the passive elements. Okay, if there is no any energy source, we can consider that is are the passive circuits. Then we'll see what is a bilateral and unilateral circuit. Bilateral circuit is the circuit which works in one direction without changing its properties. Okay, so in bilateral circuit is a circuit which works in either direction. Okay, in either direction it is working without change its properties, such as overhead lines. In overhead lines we can transmit the current from sending end to receiving end or receiving end to sending end. Cables, again cables sending end to receiving end, receiving end to sending end. Wires also we can say that it is a bilateral network. Unilateral circuit is the circuit whose parameter depends upon the direction. Whose parameter depends upon the direction, it is called as the unilateral, such as direction that works in only one direction. Let us consider example a diode. Diode works conduct only when it is a forward bias. When it is a reverse bias, it will not conduct. Okay, so it will be in the blocking state. So we can say that diode is the unilateral circuit. Okay, diode is the unilateral circuit. Linear and non-linear circuits. In linear circuits and non-linear circuit, it consists the linear elements such as resistance, inductance and capacitance, it which remains the constant with variation of voltage and current. Okay, so resistance, inductance and capacitance will never change, it remains a constant with respect to the change in the voltage and current. That is VR is equal to IR, VL is equal to minus L di by dt, VC is equal to 1 upon C I di by dt, where VI characteristic of circuit is always a straight line. In nonlinear circuits, the parameter changes with the voltage and current. Okay, the parameter changes with the voltage and current, which is happens in case of diode, thermistor, silicon carbide, or you can say SCR. Okay, triac, this that is power electronic devices. All in all these cases, VI characteristics is a non-linear. Okay, so then lumped and distributed circuit, a circuit which represents physically separated elements such as resistance, inductance and capacitance is RLC circuit. Okay, in lumped circuit we can separate out the resistance, inductance and capacitance, and we can show at a one location, so then it is called as the lumped network. In distributed network, that cannot be electrically isolated. Take example of transmission line. In transmission line, having the resistance, transmission line is having inductance, transmission line is having capacitance, but we cannot separate it out. Hence that parameters are the distributed in case of transmission line, especially in case of long transmission line. Okay, so in this thank you. In the next lecture we will see the classification of sources, what are the electrical sources. Okay, so that we'll see in the next lecture. Thank you.